Okay, starting at 17. Molarity problems. Well, molarity equals moles of solute over liters of solution. So knowing this and knowing that it's on the back of the periodic table right here is going to help you greatly. So I have 90 grams of C6H12O6 and 2.5 liters of solution. Only I don't see grams in my formula. I see moles. So I have to do a mole. I have to do a mole conversion. I have to do 90 grams of C6H12O6 into moles, grams, moles, C6H12O6. Okay, 1 mole. And so, let's see, 12 times 6 equals plus 12 equals plus 6 times 16 in parentheses equals. So I've got 180 grams of C6H12O6 in each mole. If I divide 90 by 180, that's equal to 0.5 moles. So now I have 0.5 moles. I have the liters of solution. Now I can tell what my molarity is. 0.5 divided by 2.5 equals 0.2. 0.2 molar solution. Now, keep in mind that this has to be liters and this has to be moles. If it's in milliliters, then you have to convert it to liters, right? And if this is in grams, you have to convert it to moles. All right, how many liters of water are needed to produce 2.5 molar, 2.4 molar solution? Sorry about that. Oh, no, not again. Okay, let's not freak out. Let's just do this. And voila. Okay, 2.4 molar equals, and we have X liters. They want to know how many liters. And we have 176 grams of LiCl, so we have another conversion to do. We have 176 grams LiCl to convert into moles. LiCl, grams, LiCl. LiCl, let's see, 6.91. I'm just going to call that 7 plus Cl, which is 35.4. So I have a 42.4 grams is 1 mole. So 176 divided by 42.4 equals 4.15 moles. And then we have to solve for X, so these two things switch places. So that number divided by 2.4 equals X equals 1.729 liters of solution, liters of water to produce that solution. Okay, how many grams of CCl4 would be dissolved in 2 liters of a 0.6? Okay, so now they've made X moles, and we're going to have to convert that to grams, so we're going to be converting moles of CCl4, moles CCl4 to grams CCl4, 1 mole. We got to get that number there. So, and we've got 2 liters, and we have 0.6 molar. So it's just basically figuring out what your unknown is and then what. So 2 times 0.6 enter. So I have 1.2 moles. So X equals 1.2 moles. And then how many grams of CCl4? So 35.4 times 4 plus 1 carbon is 153.6 times 1.2 equals 184.32 grams of CCl4. That is my answer. So I had to actually do this a little backwards. They're asking me how many grams. I had to figure out how many moles. So X moles, 2 liters, 0.6 molar. I got 1.2 moles. Then I plug that in to a conversion to go from moles to grams, and that gives me 184.32 grams. I do not like this chart. I refuse to use this chart. I'm not going to look at this chart. That chart means nothing to me, so let's carry on. All right, taste bitter, sounds like a base. Taste sour, sounds like an acid. pH 3.75, acid. Remember, acids are 0 to 6.9. Pure water, that is neutral. HNO3, if there's a hydrogen in front of it, the whole definition of an acid is that it has a proton that it can donate. That is that proton. This is an acid. Soapy solution, well, we clean with bases. Turns litmus paper blue. So if it turns blue, bases turn blue. Gives hydrogen away. That's acids, textbook. pH 7 is neutral. Slippery, bases. Hopefully you'll go through all those things about acids and bases. You need to know all those things, all the general properties of acids and bases. Yes, you need to know that stuff. Cleaning stuff is okay. Here they're asking strong acid, strong base, weak base. The definition of a strong acid or strong base is that it dissociates 100%. That is the textbook definition. So if it dissociates 80% and it is a pH over 7, that is a weak base. If pH paper turns red, and it dissociates 100%, that is a strong acid. Remember, acids turn blue, litmus paper red. And strong acids dissociate 100%. pH paper turns blue, so that's a base, but this light is dim. This is called an electrolyte. When you put acids or bases into water, they form electrolytes, and they can flow electricity really well if they dissociate 100%. If they dissociate at 50%, then the light is going to be dim. If they dissociate at 100%, then the light is going to be bright. So I know this is a base. It turns pH paper blue, but it is a weak base. And I know that this is reactive with metal, so it's an acid, and I know that this light is bright, so this is a strong acid. So they've basically given me 2 weak bases and 2 strong acids. Okay, and we shall continue. Okay, an acid that completely dissociates into ions in a solution is known as a strong acid. We've discussed this. An example of this acid is shown by the following equation. Well, I have HNO3, I have H2O, H, and NO3. So, yeah. That is an incorrect thing, by the way. That is an incorrect equation. That's incorrect. That's not what happens. That's 100% not what happens. But anyway, an acid that only, they're showing you that the ions are there, but what they're not showing you is that there's also water there, or H3O. An acid that only partially dissociates in a solution is known as a weak acid. And then they've given you acetic acid. This plus H2O is 8, and they're showing you the dissociation, but they're not showing you that there's water there. And it's a spectator, but if you're going to show it in the first part, you got to show it in the second part. The reaction between magnesium hydroxide and phosphoric acid. Okay, so we have magnesium hydroxide plus phosphoric acid. So we have phosphoric. So that's a phosphate. So that is H3PO4. H3PO4 goes to, and then we make, let's see, an Mg, oh my goodness, 3PO4, 2 plus H2O. Yep. Yeah, that's it. And this is called, okay, so we have a salt and water. This is called a neutralization reaction.
Mr. John McDaniel, if you could please return to A114. Please return to A114, Mr. McDaniel. Thank you so much.
Okay, that is a neutralization. I don't know why they're not using the things that we talked about in class. Like we talked about hydroxides and acids, but we didn't talk about polyprotics or weak, and we didn't talk about salts that contain a polyatomic ion. But I guess they're just trying to use all the hardest things for you. So lucky you. In a neutralization reaction, the reactants would be an acid and a base, producing water and a salt. And usually NaOH plus HCl goes to H2O plus NaCl. So you see water, you see a salt. This is called a neutralization reaction. Identify the acid, salt, and acid base, salt, and water for the neutralization. Well, this is new and different. All right, well, the acids are easy. They're the things with the H's in front of them. The bases are easy because they all have a hydroxide. The water is easy because, I mean, if you don't know that water is H2O by now, then I don't know what to do. So the only thing left is the salt. That's pretty dang easy. All right, heat. Specific heat. This is a long review. I'm going to pause it there and do another one.